we're going to start in a minute. Anyways.
Everyone's recording.
Whoa, smooth.
What happened?
Oh, I just like all of the technical difficulties have been resolved before we began this time.
Yeah,
this is great.
Yeah.
Yes.
I
think. No, I hit record.
Yeah, it's
Pause recording, start recording.
where's the white gun? You see on my end?
Oh, I spoke too soon. Did it restart?
No, I'm going to need the host. So now you can
Oh, okay. It's recording. Put up chat. Yeah, I was gonna get through there. Okay, so real quick message for the online participant. To field your questions, please submit them in the chat for the group chat, and then I will try and catch those as they come in. My computer should give me a notification when a question is submitted. Okay, for those of us in the room, let's go ahead and start. Greetings, everyone, and welcome to the Collaboratory's Intro to Programming in Python. My name is Alex Bremer. I'm a postdoc here in biomathematics and ecology evolutionary biology. I use models from physics and math and biology to model lung cancer and study medical images. And I also use a lot of programming, hence sort of my background in teaching this course. I'm excited for the turnout we have for the workshop. At the start of the holidays, we had about 4 people registered, and then in the last week, we've quadrupled the numbers. So this is great turnout. A few points I want to make about the format for the workshop, and then I'm going to hand out a survey for this workshop as well, and then we'll get started. Okay, great. So in terms of the pace schedule, the workshop is scheduled for 3 hours a day. I'm not going to go straight through the 3 hours. We'll take a break about halfway through. There aren't really any assignments with the workshop unless you're taking this for credit. I blank on the numbers because there's different course register numbers for the credit, but if you are, you know you are. In order to get the credit, basically every day, multiple points, we're going to work on small programming activities. So if you're taking this course for credit, I'm going to ask that you email me the code that you wrote for those activities at the end of each day. And I have a roster with this information, so I'll reach out to you individually and do that for each day as well. Now, for workshop content, you all, when you register for this workshop, you checked a box that basically ranked your prior experience with working in Python. Based off the responses from that, I am working off the assumption, blanket assumption of 0 experience in programming, period. It worked well last time we taught this workshop in the previous quarter, and so we're going to do that again as well, especially based off of the responses for the surveys. So we'll be covering very basic fundamental aspects of programming in Python. Now, there's a whole lot that's possible that you can do in Python, even at this sort of introductory level. We could focus on many different things. I want to make very clear what we won't cover in this workshop and which workshops you could look at in the Collaboratory to get that material. Basically, we won't be graphing. We won't be studying ways of solving differential equations, either numerically or symbolically, and we won't be analyzing images. Those topics are, there's enough interest in those topics individually that we have separate workshops just for those topics. So let's see if I can point here. Yeah, so Advanced Python is a great workshop. Basically, everything you learn from here will really help you go into that workshop, and then you can learn about making graphs with Python, maybe doing some basic numerical modeling with Python. Or if you're more interested in analyzing images using Python, and Python is a great language for doing that. It's the main reason I use it. We have a whole separate workshop just for that, and both of those workshops are going to be offered this quarter. Occasionally, we have a machine learning course in Python. We haven't, I don't think that's scheduled for this quarter. That may happen next quarter, though. So keep your ears open if you're interested in that. Okay. So go back here. Next thing, I don't use slides when I teach programming. Basically, you're each going to be, from this page, you're going to download what's called a script. And it's kind of like a tutorial handout package with blank sections and lots of text that narrates along the way. And then we as a class will type into the blank sections. So that way you'll get an actual sort of tactile learning experience as we go through learning Python together. At the end of the day, in case, so don't worry if you feel like you got left behind during those scripts. At the end of the day, I'll email out my copy of those scripts that I'm working from, like the solution set you could see. So at the start of each day, we'll all point to where we download the new script for the day, and then at the end of the day, I'll send you the solutions version of the script. And then periodically throughout the days, we'll be breaking into groups, quote unquote, to work on more challenging programming tasks, and they'll be anywhere from 10 to 15 minutes to maybe a whole 30-minute chunk of time, depending on the scale of the task and how we're going through them as a group. The idea with those is to try and synthesize what we've learned up to that point, and get you some experience in the class where I'm available, where your peers are available, to try and actually troubleshoot and experience programming on the spot. So, okay, are there any questions from folks on those announcements for the course in a nutshell? Great. I will also try and point out other resources available online to you folks as we go through, and anything I don't get to along the way, I'll just show you in mass at the end of the workshop. Right now, I'm going to hand out a survey that is, well, it's a couple things. It's a survey and it's a consent to participate in research. So in addition to the, what do we say? Traditional research that I do, I'm also doing some educational research to try and experiment with different approaches to teaching programming in the university environment. So this is all voluntary. This isn't obviously required. It won't affect your grade if you're taking this course for a grade. And it arguably won't affect, in a negative way, your learning of the material. So I'm going to scan through the main important parts from this consent to participate in research, and then we'll spend about 5 to 10 minutes filling up the survey on those last couple of pages. Why is this study being done? I'm studying the effectiveness of different teaching methods that have been shown to positively influence student learning experiences in STEM courses, specifically programming. The data I'm going to be collecting is only in survey format to assess your attitudes and beliefs regarding computer science and programming and how those change based on the structure of the workshop. In other words, I'm trying to find better ways to run the workshop. So all the data will be anonymous and used in aggregate to protect identities. What we do is we have you each generate a unique key based off of the 6 digits for your birthday and the last 4 digits of your phone number. You merge those together to form one 10-digit long signifying key that ideally should be easy to remember. Okay, what will happen if you take part in this research study? If you volunteer to participate, I'm going to ask you to do the following things. Take these 2 5 to 10 minute pre and post surveys of your attitudes and beliefs about programming and computer science. Allow me to link your responses to those surveys so we can track how these change over time. As I mentioned, again, your identity will remain anonymous by use of this code. And then finally, what we're actually going to be doing in regards to this is practice what's called working in paired programming. So when we get to those tasks I mentioned at those various points during the day, you'll break off into pairs for working on those tasks. And the clincher is that there'll only be one computer for the two people working in the pair. And so we're just to see how that practice influences your experience. And I've got these cards I'll hand out to help you kind of randomly identify your pairs. Good, right, sorry, okay. How long participation will take about 10 to 20 minutes outside of programming activities, and that's mainly the surveys. Are there any potential risks or discomforts that you can expect from the study? No, there are no anticipated risks or discomforts. Potential benefits, you may benefit from the study by learning more about your attitudes and beliefs in relation to programming and computer science, and the results of this research may affect changes in the way courses are taught at UCLA within these workshops. All information will be kept confidential. You are completely free to not participate in this, either in the survey or in the pairs. Just please make clear that when we do the pairing, if you're not going to participate, then you don't pair with someone who isn't going to. Sure. I'm the host. I can start recording. I think we are recording. Yep.
You're all good.
On recording. I'm host. Thanks, Elroy. Sorry about that.
Yeah.
And while you folks are filling that out, I'm going to go through the roster and take roll for attendance. So please, when you hear your name, just raise your hand or stay here, and I can get you down for attendance. So Naomi Barber, perfect. Theodosia, oh yeah, great, thanks. Boué Hu, thank you. Tanner Dulay, thank you. Nyasha Maforo, thank you. Golnush, yep, thank you. Neha Batra, thank you. George Phillips, okay, thank you. Xiao Ron, thanks. Negan Rahim, thanks. Caroline is online. Natika Sharma, thank you. Fangfei Guo, okay. Alexis Weber, okay. Emily is online. Grace Rami, Grace, okay. Emily, oh, two Emilys. Oh, okay, let's try that again. Emily Noronha, that's online, and then Emily Ng. I don't know which Emily's on. Okay, Johnny Lee, and Georgia Del Vecchio. Okay, thank you. Let's see. Okay. No sound. And if you haven't already, once you finish that survey, if you could please navigate to the web address for the screen projected on the board, on the screen. Sorry, I've written the web address down here on the board as well, because we're going to download the file from there for use for today's workshop.
Yeah, that's it. So Carolina. Okay, just bring that to my desk after.
Sure. What do you mean? Interesting. Okay. Okay, thank you, folks. And as I mentioned, we'll come back to the active part of this. Activities for the survey later. So for those of you who have those cards, please just go ahead and hang on to those little tags. We're going to use those for the matching coming up later. So, okay, the files for the course, I have these hosted on a website that's called GitHub. GitHub is a very nice website repository for storing code. So as you start to work on more of your own programming and working on your own code and start to do it collaboratively and working with other people and sharing code, you'll start to run into version control issues where maybe you change the code and someone else then has to use it. And if you're both working on it at the same time, you could run into conflicts as you edit that code. It's the same idea as when you're editing papers with co-authors and maybe you're both editing your own version and then you try to merge those versions, you have conflicts. I won't talk about how GitHub actually works. I hope it's just merely introducing you to it in this format will be helpful enough to kind of help get you thinking about considering using it on your own. But it does serve as a nice location for storing files in the same sense as Google Drive or Dropbox or Box or so many options. So if from this page, you'll see okay, so there's a license, there's a README, as it's arguably copyrighted material, and then right here is a file for today. It's called day1_student.py. So this means this is your file for the first day of the workshop. .py means it's a Python file. Go ahead and click on the clone or download button on this page, and then download as a zip to download these files to your desktop. And then at the end of the workshop, as I mentioned, I'll post online to this page my instructor's versions of these Python files that we're using to practice with Python. So I'm going to minimize this page. And then this download, I'm going to drag it onto my desktop, open, and now I have this introductory Python collaboratory folder that's going to contain today's files. So don't worry about double clicking on this Py file to open it. Instead, we're going to open it from within an application. So on your machines, open Anaconda or the Anaconda Navigator. On Macs, you can do this with the Spotlight searching and just type in Anaconda and it should pop up. On PCs, I forget the hotkeys for browsing your files, Command F. I think for PCs, if it's similar as a shoe, slightly different. Okay, and then okay, so we're going to be using something called Spyder for most of the workshop. We'll use this object called Jupyter towards the end of the day, just real quickly to show you what it is and how it works. But for most of what we're doing, it'll be this thing called Spyder. So go ahead, go to Spyder and click on Launch. Excellent. Get some updates that there's a new version available. That's fine. Okay. Your font size probably doesn't look quite so hideously large. I did this so that it's easier for everyone to see what's on the screen since you're reading typed font. Excuse me. And then from within Spyder, your tabs probably look something like this on the left. So go ahead and go to File and then Open. And now navigate to where you saved those day one student.py files from GitHub. So for me, that's on my desktop. And I have introductory Python collaboratory master, day one student.py. So you should all have on the left half of your Spyder screen, something that looks like this: collaboratory workshop, intro to Python day 1 out of 3, and then a whole lot of text. And then that's where we'll start. So quick show of hands if you are on this page or are getting to this page. Not quite. Okay. So I'll come around.
Do you not have Python downloaded yet? No. Okay, you should switch to a desktop because it can take a while to install.
1 minute.
Okay.
Yeah.
If it looks like it's going to start to take more than 5 minutes, switching to a desktop. Oh, great, yeah, Spyder's open. Perfect, so soon. You're there. Working, excellent. Good. Great, okay, cool.
Okay. So, I promise we're very close to actually typing our first lines of code in Python. But first we do have to speak a bit about what Spyder, Python, and all these things are and how we're going to use them. Okay, I just took a guess at the font size. Is this large enough for folks in the back? Terrific. Okay, so that a little bit. That's fine. Okay. So again, welcome. This day we're going to talk about the format of that. Sorry, I said the format. Spyder, Ipython, and Python. And then here are some of the things we're going to learn about during today, namely assignment and variables, mathematical operations, reassignment, floats, integers, and other object types, text strings, what logicals are. We won't talk about indexing, that's coming tomorrow. We will talk a little bit about true and false conditionals, if-else statements, and functions. And then that's a lot. That's how the workshop will be. We're gonna just sort of drag you through a ton of different things that are available in Python. And then we'll get some examples of how to use them along the way. So this workshop aims to teach you some of the basics of coding in Python. As I already mentioned, the collaboratory offers several other Python workshops that are all very nice and supplementary to each other. So as that being said, we're not going to cover many of the things you may otherwise find in a first course in programming. More talk about the breakdown of the workshop we've discussed and how these work. This is an important point. Most of programming is troubleshooting. I encourage you to type along and we will address any questions or problems or errors as they arise. My own coding results in errors every single day. It's a natural part of programming. It's called debugging. So don't let error messages dismay you from continuing. So what is Spyder, this thing we're using, and how does it communicate with whatever Python is, this workshop you're enrolled in? So the Spyder Integrated Development Environment, or IDE, is a computer program that has both what's called Ipython and what's called a text editor. You are reading from the text editor. This whole side on the left half of the screen is the text editor. That's what we're going to type in, kind of like a word. Ipython is an interpreter for Python. Ipython is a computer application that allows you to execute Python commands and programs. Python itself is the programming language. It's the language that you write the computer programs in. You can think of Python as the grammar and the style and the punctuation with which you write the code. It's literally a language in and of itself. Ipython then reads, interprets, and executes that code, hence why it's called an interpreter, and many other things like it are all called interpreters. And then finally, Spyder is the software that lets you do all of these things at once in a structured environment in an application. So within Spyder, we have the text editor, as I mentioned, this window that you're reading the text from, the left half of the screen. On the right half of the screen, in the upper half, we have what's called the variable or file explorer and a help menu. We'll talk a little bit more about what those are, obviously, as we start to actually use them. But basically, as you maybe import data into Python to work with it, the existence of the data in Python would make itself known in this variable or file explorer window. And then finally, in the bottom right is what's called the Ipython Console, which will basically print out the code that you execute, as well as the output of your code all at once. So we can execute code both in the console, in the bottom right area here. Notice I click on it, and now there's a flashing cursor, and I can type in this part of the screen. We can execute code there. We can also execute code from within the text editor itself by running chunks of code called cells, or by running the entire text editor file all at once. Spyder, unlike other languages or IDEs, will not run Python code line by line. So for example, if you have a line of text or a line of code and then there's a line break for another line, Python's going to just read all of that until it comes to the end of the cell. R is a very popular language people may be familiar with. R will do line by line reading automatically. So it's important to know that if you try and execute a line of code in Python, it's going to keep going until it hits the end of the cell. So how do we define cells? The combination of characters pound, ampersand, ampersand, defines the beginning and end of a cell. So every time, so you'll notice here, I have pound, ampersand, ampersand, and there's this red line that is now made right above that line. I can do this again, and then I've defined a separate cell. And so when you're in different cells, they're highlighted, and on my screen, well, maybe it shows up grayish on the screen there, but on my computer it shows up kind of rose pink colored. Okay, so with each of these cells we can write a block of code that can be executed independently of the other cells using hotkeys. On our machines it's going to be Control Return or Control Shift Return, or you can click on the right pointing green arrow at the top of the screen up here, and that'll execute the cell. I encourage you to learn hotkeys. The less you can remove your hands from the keyboard as you're programming, the more fluid your programming experience will be. And so I encourage you to try not to practice too much running code by pressing the green triangle button. Okay. So the cells. I use these cells because it gives us a natural way to set up a tutorial where every block of code that we want to run is entered in a separate cell. If you've worked with Python code much before, you might think, why am I doing this approach? It is a bit arduous. It's not how people tend to code in Python. I think for our purposes, it's fine for what we're doing. But it will hopefully make some more sense later on as we start to work with different aspects of Python. Along the way of the workshop, though, we will experiment with some of the other approaches to using Python, what's called scripting, running Python from your command line or your terminal, and then also using something that's called Jupyter, which is like a web-based version of Spyder. Okay. Now, if you type only a single pound symbol without the ampersands, then you are defining what's called a comment or a block of commented code. Commented code is code that the interpreter will not read, and hence it will not be executed, which allows you to narrate and describe what your code does. This is a really valuable thing to do, to practice, both for yourself and for your peers when you share your code with them. It's extremely easy to write your code, get it to do what you want it to do, use it, save it, forget about it, come back to it a few weeks later, a few months later, a few years later, and if there's no comments, there's no explanations of what it does, then you may forget completely what it's actually doing. And so typing your own comments about what your code is doing is a very, very beneficial way to kind of remind yourself or your peers in the future what your code does. Okay, finally, executing cells and executing our first line of code. So to execute a cell in Spyder, press Control and Enter. We can try it in this cell. Control Enter, nothing will happen. Cursor doesn't move, nothing changes in the bottom right corner of the screen where I said the output will appear, and that's because all we have in this cell is a comment. There is no code that will be executed. We can try a different set of hotkeys, Control Shift Enter, which attempts to run the code in a given cell and then advance to the next cell. So that obviously works. If I go back to this middle cell, press Control Shift Return, we executed a comment, so nothing happened, and then the cursor advanced to the next cell, which was boring, but the point is everything's working as advertised. So now let's execute our actual first line of Python code without kicking the connection for the screen too many times. Okay, so together, we're going to use what's called the print function, which is the word print followed by in parentheses and then in quotation marks, the phrase hello world. So now if I press Control Return, I have something new in the console. I have the line of code that I typed and executed, which is the function print, parentheses, quotes, hello world, close quotes, close parentheses, and then the output of executing that line of code, which is simply just the text, hello world. Okay. Great. We ran our first line of code. So a couple things to comment on what just happened, and then questions, and then we'll move on. This print function is one way of making sure that output is printed for commands for multiple lines. We could have left this without the print function, press Control Return, and Python will still execute that line and just return that string. But if we had a second line after it, for example, caret, then Python only prints the last thing that was in that cell, the caret. It doesn't print the first line, which was hello world. And you see that by, okay, so it reproduces the code that you told it to execute, but then here, following the out marker, says only caret, not both hello world. So if we want to make sure that we can view all of the output associated with what we've typed, then we use this print function each time. So I'll try that example now with both of these statements in print functions, and now we have both outputs being presented. Okay. Any questions from folks so far on Spyder, Python, IPython, or this one first simple use of this print function and executing code? Okay, moving on. So, assignment of simple variables. When we're programming, we're often going to want to do what's called assignment and assign variables to names. Maybe you read a file into Python, maybe you want to store a special number that represents the slope of some fit you performed or the average value of some data you have, and you want to save it to a value so you can call it back up later. You don't have to scroll through the whole output console to find the value. Assignment is what lets you assign a value or a file or some other abstract object to a name, and then that name is used in Python to call that object back up. There are several different types of what are called basic variables, common across many languages, different programming languages. And these are strings or characters. So text, namely, but really any combination of numbers, letters, and special characters or spaces. And then there's integers, floats, floating point numbers, so non-integers, and then Booleans, true or false, also called logical sometimes. Let's see. It may seem odd to you that we would care about using objects like true and false, but they're rather fundamental in programming. They allow us to do lots of nice ways of sort of sifting through our data, because we can ask questions like, is this value larger or smaller than another value? And then that's called a logical operation or a true or false calculation. Many of the variable types do exist. You can even create your own variable types. We'll explore some variable types. We won't talk about creating our own variable types in here. We're going to focus on ones that are particular to Python. But all the ones we just mentioned are pretty common. For example, they're in R and MATLAB. So, excuse me. Let's practice with strings. So we're going to assign the string phrase. This is our first string to the variable named some text. So I'll type some text on its own. And that'll represent the name of the following variable. And to do assignment, we use a single equal sign. And then I'll type in quotes, double quotes, excuse me. This is our first string. So you'll see in here I have numbers, letters, special characters, that little caret symbol, spaces. When I press Control, return, we see here in the console a line for input in 5. Some text equals this is our first string, no output. Because it didn't ask for Python to do anything with it. It didn't use the print function, which generates printed output. So all Python did was read this statement as some text equals, literally, some text. Now, if we go in the upper right part of the Spyder environment, there is this help button for the internal help searcher. There's the file explorer where you can navigate all the folders and files on your machines. Or there's the variable explorer tab, which lists the variables that we've defined in our working active session with Spyder. It tells you the name, some text, it tells you the type, str, short for string, its size, which is an odd way of thinking about dimensionality, and then the value, which in this case is all the characters that make up that string. This is our first caret string. Now we can tell Python to print the value of the variable, some text, using the print function again. I'm going to type print, parentheses. Excuse me. I should warn, I am on the very tail end of a cold, so I will likely be coughing periodically throughout the workshop, but hopefully less and less as it goes on. So if we type print and then in parentheses some text and press Control, return, then that tells Python we want it to print the value represented by the variable name some text. And so the output from that is the value of some text, which is, this is our first string. That statement that we assigned to the variable name some text. Previously, when we said print quotes hello world, we were doing the same thing here. We just weren't using the variable name as a go-between in those two cases. Okay. Assignment is the same no matter the type of variable you're working with. It can be an integer, or it can be text, or it can be file. We do the same thing. We write down the name. So I'm going to do some integer, and then equals and the number 42. So I'm going to assign the integer 42 to the variable name some integer. Press Command Return. And now we have a new object in our variable explorer in the upper right part of the screen. Some integer, it tells the type, int, size 1, value 42. And as before, we can ask Python to print the value of the variable name, some integer, by typing print, open parentheses, the name of the variable, some integer, and then press command return. And Python will print out the value in the console output 42. Okay. Maybe we like to see the values of both of these variables. You can do this a couple of ways. You can type print some text and then press return in a new line, print some integer. And then if we press command return on this cell, then Python goes line by line. It prints the value of some text, and then it prints the value of some integer. So first we have, this is our first string, and then 42. It's going to work sequentially. In this case, top down, but it also reads left to right. What I mean by that, if instead of using 2 print functions, we just did 1 print function, so I now have inside of the one same print function, both variable names, but separated by a comma, and press command return. Same thing happens, only now they're not separated by lines. They're just separated by one single character white space. But still printed in the order in which they were queried. The text first, then the integer. Okay. You can simply just type the name, the variable name. So for example, we can do some text, press command return. And so we have the input is some text, the output is, this is our first string. Same thing works with some integer. Output is now 42. But if I typed both some integer and then some text, both these variable names in the same cell, and press command return, and same as before, the last one that shows up is the only one who prints the output for. So if you wanted to again see them all, then you need to put them both inside of either the same print function or 2 separate print functions. Okay, and then the last one for this section. Excuse me. Oh, yes. Sorry, can you say the first part again?
You said that unlike Spyder reads the entire cell together and not line by line.
Right.
So when you run some text here, you still don't get some integer. It's still reading it line by line, right?
Yeah, but it's only printing out what showed up in the last line. And I don't have a good explanation for why it's specifically not printing everything before and why you have to put in a print function for each case. I can just say you have to. If you're, it's still performing those operations. It's only going to provide output for that last thing that's there. Yeah, yeah. And so everything's still being executed. It's just not being executed with, yeah, with an output print. Okay. Let's double. Okay. Finally, I'll practice real quick with a Boolean. So we could call this a Boolean is the name of this last variable. It'll be equal to, okay, true or false objects. They're case sensitive in Python. So we're going to save the value of true to a variable name, a Boolean, as if we wanted to use it again later, like the integer example or the text example. If we're doing that, if we're using these logicals, these trues and falses, or these Booleans, we have to type them with the first letter capitalized and everything else lowercase. Once you get that spelling correctly, then they'll, a text editor like Spyder will automatically recognize that and change the font color for that block of text, because it recognizes that as a true or false object. In other words, you can't use capital T lowercase RUE as a variable name separately. Those 4 letters in that combination of cases is reserved within Python for special use. That being said, you can't just use capital T as an abbreviation for true, and the same with false. You can't use a capital F as an abbreviation for false. It has to be capital F, lowercase ALSE, and then it gets recognized as a special Boolean object. That again is a little bit different. R, you can use just the first letter for trues and falses. And they're also all capitalized. Okay. Right, and then finally, if we wanted to print the value of this variable named a Boolean, we'd type in the print function a Boolean, and then in the output, we just get the response true in the console. Any questions here on these different data types and these examples with the print function? Okay, let's keep going. Keeping that thing over. Types and then break there. Great. Okay, so some mathematical operations. You can use Spyder, you can use Python basically like a giant calculator if you like. So here a little quick practice, the different mathematical operations. All of your favorite basic mathematical operations are available in Python with respective commands. So addition, subtraction, division, multiplication, exponentiation shows up as you use the same character for multiplication, but you just use it twice. And then the modulo operation, or the remainder, is represented by the ampersand symbol. And then finally, asking for equality between 2 numerical values is done using 2 equal signs. There are many more mathematical functions available. The trig functions, common exponential functions, but they're not in the sort of base version of Python that we work with. We have to do what's called loading a package or loading a module to use those, which we will practice with some tomorrow. So real quick addition. Gonna keep having us practice using this print function, and inside the print function we'll practice addition. So we have 2 plus 2 and command return, and in our output console we have the value 4. Subtraction, as I mentioned, is the minus sign or the dash or hyphen. Press command return, we have 0 when subtracting 2 from 2. Division is the / operator or key. So 2 divided by 2 gives us 1.0 for the output. Multiplication is the single asterisk, so 2 times 2. We have 4. Exponentiation, as we mentioned, is double asterisk. So we'll do 2 double asterisk, sees the value 3, so we can tell it's not the same as 2 times 2. Command return, and our output is 8. The remainder or modulo operation will do 1, remainder 3. Press command return, and we get the output of 1. So that's read as, if you want to know the remainder of 1 when divided by 3, that value is output 1, which represents the value in the numerator of the fraction left over from doing the division of 1 by 3. Then finally, asking for equality. We can type 2 double equals 3. Press control return, and then the output we have is false. Right, 2 is not equal to 3 on the number line. If we want to make sure this works and gets a true answer, we can do 2 double equals 2, press command return, and now our outputs are false and true because we had 2 things that we ran in that cell, 2 equals 3, 2 equals 2, and so Python printed whether these are true or false statements for each case. Any questions on mathematical operations? Cool. Okay, reassignment of variables. So there's an idea called a reassignment in programming where you assign a value to an existing variable. It may seem like a trivial, obvious thing. If I assign the variable name a to the number 2, I could always assign the variable a to another value. Why does it? Like, obviously, but we typically think about reassignment in more than just reusing a variable name, but maybe for updating values as some type of procedure is being performed. So, for example, we already have the variable some integer defined, it equals 42 above, but when I do a reassignment of a variable, I can include the variable name on the other side of the equal sign. So I can say some integer, I want to assign it to equal the value of some integer itself plus a value of 4. So now, after you run this once, the value of some integer should change in your variable explorer from 42 to 46. If you'd like to make sure you see that happen, then you can type print some integer exactly afterward. And then when you run this all at once, the first line will be executed, which is Python updating the value of some integer to a new value. And then the second activity will be printing the new value of some integer to the output in the console. I'll press that and control return. Since this is the first time I ran either of those lines, I now have in my console the repeated input, some integer equals some integer plus 4, print the value, and then finally the output is just the value 46. Okay. Any questions on reassignment? It's a quick thing we point out, but we'll come back and use it again pretty regularly in the rest of the workshop. Yes. Yes. Fair. There. No. Within a single line, Python is not case sensitive. I do that just to make it legible. So the question is Python space sensitive? So if in the single line, you notice I wrote some integer space equals some integer plus 4. You could have typed that whole thing without any spaces, and the exact same thing would have happened. I mean, now it'd be plus 4, so go up by 8, but it would still work. I do this just to try and make it a little more clear, especially since I'm running this tutorial workshop, so you folks have to follow what I'm typing up on the screen. So I tend to use white space quite a lot for that purpose, but it won't affect your output. However, once we start writing code that spans multiple lines, maybe writing functions or if-else statements or loops, at that point, white space will matter. Python does something, it automatically indents blocks of code. It does that so that you don't have to use as many other called delimiters, colons, parentheses, brackets, to try and organize the different blocks. People like it, people hate it. I like it because it formats the code in a nice legible way, but then it also means that if you don't have your tabs in the right spot, then sections of code get interpreted differently. And when we get to there, I'll be very careful to point out what's happening in that instance. But for these single lines, these spaces don't change anything. Okay, floats and integers, really floats. So a couple of quick comments I want to make about differences between floats and integers. And this is really going to get us down to rounding and truncation error. We're not going to delve deeply into this, just going to do a couple of quick examples and talk about it for a couple minutes. But if your interest in using Python is in doing statistics or in doing numerical integration or differentiation, solving systems of equations, and you're worried about round-off error, truncation, these are things that you'll want to be thinking about and be mindful of in the future. So as I mentioned before, integers are the counting numbers. They're positive, they're negative, but they don't have decimals or commas associated with them. Floats, on the other hand, are expressed with decimals or in scientific notation. The phrase float is short for floating point number, where the phrase floating point expresses the fact that some truncation error exists depending on what's called the bit type of the float, or very naively, how many electrons are being used to store the number in your computer. A very thorough discussion of bit types and what's called machine epsilon, or the sort of fundamental limit that your computer has, are far outside the scope of this course. But now those phrases are familiar and you can Google them later. So I'll say in short just two things. One, even for computers, they're imprecise and they don't have infinite accuracy. And two, at some point, rounding is always occurring. So I'll do a couple of quick calculations to demonstrate these two ideas. For point one, have Python print the two following operations. We're going to take the value 1 and add to it 1 times 10 to the minus 15. And again, take the value 1 and add to it 1 times 10 to the minus 16. We want to see what the two outputs look like to see if we get the same thing. In other words, how small of a number can you add to another number before you're no longer, well, yeah, let's say that. So first one, print 1 plus 1e minus 15. And then the next one is print 1 plus 1e minus 16. Press command return. And in the console, I have two different outputs. The first output, where we added 1e minus 15, I actually have 1 point, okay, that should be about 14 zeros and then a 1. In the next case, we just have 1. There is no 1, very small 1 added to it. We reached the machine epsilon, you might say, or we reached the truncation limit for these floating point numbers in Python. And so Python just said, that's enough. We're not going to store that much information. We're truncating this off. Finally, for the second point, similar idea of adding two numbers together. We'll do 1.2 times 10 to the 8 plus 2.5 times 10 to the negative 7. Then I'm going to highlight this line, copy, and then paste it twice. I'm going to change these minus 7s on the far right end to a minus 8 and then to minus 9. So similar idea as before, but we're going to have a slightly different change in output now. So I press command return. Trying to make the console a bit bigger. So we did these three different operations as the input. We took the same first number, 1.2 times 10 to the 8, and we added to it three different numbers of decrease in size. First 2.5 times 10 to the minus 7, then 10 to the minus 8, and then 10 to the minus 9. And now we have these three different outputs. In one case, we have what you might naively assume you would get. This first very large number added to it, a very small number. In the second case, we're right on the boundary of where that truncation occurs, but we haven't gone too far, so Python automatically rounded this 25 to a value of 3, and then added that on. And then in the fourth case, we're adding too small of a number to too large of a number. So Python just truncated the whole small number completely. Okay, so those are the two cautions I want to make when you're comparing what you think are two very close numbers together, or when you're adding very, very small numbers to very, very large numbers. In programming languages, your computers are going to truncate numbers in these instances. Any questions from folks on that idea? Yeah.
Is it possible to tell Python that you want to keep numbers beyond a certain?
You can, but you still hit a limit. So I believe these are 16-point floats. You can go in and say go to 32, and then so you technically double the length here. And in Python, I believe that's as much as you can do. In most common languages, I think that's all you can do. I don't think you can go higher than that, but you can specify it. Generally, everything just uses 16-point, and that's it, unless you specify it. In a language like C++ or C, every time you define a variable, you have to specify what type of, is it a float or is it an integer or is it string? And then if it's a float, you have to say what type. Is it 16-point, 32-point? I think you can specify 8-point if you want it to be really short. Yeah. Yeah. Any other questions? Okay. Doing great. We are nearing our first break. Yeah, perfect. Okay, so we're going to do a little bit more, and then we'll take our first break. So, excuse me, working with numbers, types, and coercion. So we'll introduce a few more functions that can be useful when you're working with collections of numbers. You may be interested in the maximum, minimum, or absolute values of numbers. These are functions that are inherent in Python, and they have sensible names like max, min, abs. In fact, Python is a rather nice language. Most of the functions are named with names that are, they sound like they do what you think they would want to do. Another way to think of it, you may often find yourself thinking, gee, I wish there was a function that would merge these two things together. And then if you go and Google Python merge function, there's a very high chance that that function exists and it merges two objects together the way you would want them to. So that's something that's worth keeping in mind in the future. Back to now, we're going to look at the example of the collection of numbers 573, 582. So we'll introduce the function for calculating the maximum of a set of numbers. It's just the letters max. I forgot to mention this. Another reason these software like Spyder are nice, they have something called tab completion. As I was typing the phrase max max, and then open the parenthesis, Python realized that I'm using the function max for calculating the maximum and is now generating automatically some of the basic information about this function below. Of course, it's in a typical help menu language, and just shows that, yes, this is a function. Inside, you add what's called an iterable, which is a list of numbers that you can iterate through, and then some other information about how you might use this function. That's not obviously helpful, so we'll skip that. But if the function name is longer, then you might actually get a whole list of function names that follow along. We'll probably see one of those as we start to type more function names soon. For now, let's just enter this list of numbers, or any list of numbers if you'd like to calculate the maximum value of. I'll be using the one 573, 582. And it was asked, spaces won't ruin this. We can add some We cannot add some, or the order obviously won't matter if I mix up the order of these, since maximum is not an order dependent thing. Yes. You do have to have commas. Yes. Excellent question. Without commas, I think this will just be read all as one large number, even if I put a space in there. Let's see what happens. Oh, automatically an X has popped up on the left. I haven't even run anything yet, which is code analysis, invalid syntax. If I remove the space, it still doesn't like what I've written, because an integer is not an iterable object. Or in other words, you can't calculate the maximum of just one number, because that's not a distribution. You can take the maximum of. So yes, we need commas here. Command return. Okay, max works. We got the maximum value was 8. The minimum function is just min. 8, 2, 5, and the minimum is 2, as we might expect. Absolute value for a negative number is just ABS. So if I want to calculate the absolute value of one negative number or a series of negative numbers, we put them inside the function ABS and press Control Return. Okay. And then if you're ever interested in the type of object you're working with, you can use the type function, type in parentheses, and then put either the variable name or the variable itself inside of this function. So I could put in here the number 10 for an integer type, press Command Return, and Python looks at the value 10 inside of the function type and outputs the type of object it is, which is an integer. We could do this with the variable name. So for example, use the variable name some integer, press Command Return, and out comes int again for the type of some integer. And this works for all the other types we might have. For floats, we can do 10.2, and it tells us that that is a float. For strings, I can put in here, in quotes, the letters for phrase, and Command Return, and I'm told that's a string. Use of this function in this way for these basic types that we kind of already, we can look at them and know what they are, may not be the most insightful use of this function. But when you start reading in files that have different types associated with them, then it can be helpful to use this function there, where it will give you some of like the basic structural information about the files that you've read into Python. Similarly, using the type function can help you diagnose issues with variable types and to help you do coercion. So coercion. Sometimes you might want to change or coerce a type in Python from one to another. Python is a language that's going to try and figure things out. So it'll assume types for different types of objects, and it may get those wrong for what you want them to actually be. This happens most often when you're analyzing data that has timestamps. Right, so the timestamps, if they're dates, they might have slashes in them, so there'll be numbers and slashes representing months, days, years. Languages like Python might have trouble with those because it might read that as a string because it's numbers and characters, when actually wanted to read that as a date type, which is a separate type altogether. Or timestamps, so hours, minutes, seconds, right? Those will be numbers in pairs separated by colons. So again, that might get read as a string where you want it to be read as a special time signature type. We'll do some simpler examples, and I'll just introduce some of these functions that you can use to change the types. So in the example we'll look at, the example will be that Python assumes the number 10 is an integer, maybe we wanted to treat 10 as a string, as in the 10th month, or the 10th file in your directory that you want to open. So to coerce a number to a string, we use the str function. So if I type str and then put the integer 10 inside, and then I press command return, then I have, because here's where the cell ends, that's why. So yeah, that's fine. We have the input, the function str, parentheses 10, and then this comment that shows up inside that cell also. And then, but finally, here's the output. Now 10 appears, but it appears with quotes, which is an indicator that it's now being treated as a string as opposed to as an integer. Maybe we want to coerce a string into a float. So what we'll do now is we'll use the float function, and we'll put into the float function in quotes 10. All right, so since the numbers 1, 0, or 10 are started by quotes, that means they're going to be recognized normally as a string, but I'm putting them inside of the float function, which is going to coerce an object into a float. So if I press command return, I now have as output 10.0. Right, so I have a floating point representation for the number 10, which means instead of it being an integer, it's been given a decimal added on to the end value 10. So we have 10.0.
There's a difference between single quotes and double quotes.
Great question. Excuse me. There is. That is even one activity we will play with later. Yes, there's a difference. In short, use double quotes always because they won't get mixed up for apostrophes. If you use single quotes and you have an apostrophe with inside of that string, then that apostrophe will be read as the end of the pair of single quotes. And if you use double quotes, you can escape that. But yeah, in a little later today, we'll see that in play exactly. So how about going strings to integers? Yeah, fine. Oh yeah, sorry, but here I'm experimenting with both. Without apostrophes, there is no difference between single quotes and double quotes. They're both fine. So we'll use the int function to coerce a string to an integer, and the string of coercing is the 10. That's now in quotes, or double quotes, excuse me. Control return. So now the output is just 10 without the added decimal at the end because it's being coerced into an integer as opposed to a float. Finally, can only coerce floats into integers, where we use the float function on the integer 10, press command return. So now the integer 10 has been turned into a float by adding the decimal point onto the end. And you might ask, can we coerce letters and punctuation or strings to floats or integers? In other words, can you use the float function to coerce the string cat, C-A-T, all in double quotes. And if I press command return, I get an error. Because the characters C-A-T or cat cannot be converted into numbers. It's an important point. You can always convert numbers into strings, but you can't always convert all possible strings into numbers, because if you don't have numbers there that represent them, then they won't turn into numbers, whether they're integers or floats. Okay, any questions on that last part on coercion and types? Okay, then we're going to take a break for 10 minutes. We'll come back at and start. 10 minutes. Yeah, perfect. 3. We'll come back at 3 and carry on with the second half of the workshop. Folks new to the building, there are restrooms on every floor. This restroom's a women's restroom. On the floor above and below is men's, and they alternate with every other floor. Cool. Hi.
Is it possible I can log in online from my lab and attend the class
Yes.
for grading also? And I can
Yeah.
submit the assignment.
Yeah.
here?
You take the class online. Yeah.
Oh, I can do that. And it's through Zoom, right?
Yes.
Can I log into the
Email
same
me.
thing?
Yeah. So the thing is, since you're registered to be in class, you won't automatically get emailed a link
Okay.
for the Zoom version of the course.
Okay.
But if you can email me today, just a message that says, "Hey, we talked. This is the plan. Let me know." Then I can forward that to the person who needs to get it.
Because yeah, I think I'm gonna run an experiment tomorrow.
Oh yeah.
So I just need to be there.
Yeah, that makes sense.
Nothing goes wrong.
Yeah, of course.
Thank you.
Yep. Just me. Yeah, of course. Oh,
So in my window, my text doesn't wrap.
oh, thank you. That's yes. We can change it in preferences. I'm so glad you said that. I always forget. So you're on a Mac? Excellent. Yeah. So if you go to Python and then preferences, and then it should be in here under editor. Yeah, perfect. So in the editor tab, yeah, here we go. Wrap lines. You check that box and then apply and OK.
Perfect. Okay. Do you use PyCharm at all?
PyCharm, no.
It's another IDE.
Yeah.
I've been playing with it, but I can't find the variable explorer on this guy.
Yeah, it might be something you have to click to open.
Yeah.
Yeah. Yeah, they're not always something that's like they use as like an automatic window.
Yeah.
You have to activate it separately.
Not a problem. And you can say no. And so I tried to uninstall Anaconda several times, and somehow the Spyder works, but Jupyter doesn't. So do you have any idea?
No, I don't. Like when you try and launch Jupyter from here.
But Spyder works.
Oh, so it'll when it does open, it should open as a browser.
It doesn't open.
Nothing happens. But even if you go to like your active browser, you don't have like a tab Jupyter there. Yeah, right, nothing there. Okay. And you don't have any. It doesn't say anything. It just stops.
And I've been trying to do this for a while now. I thought it was because the path was not added, but I tried to add the path as well.
Yeah. I was gonna say. I think that's like when you Google it. That's like the number one thing you find people are writing to. I can, so this happened with the last week of the workshop. I can send you basically the information I found online that might help resolve that. And if it does, great. If not, I wouldn't worry about it too much.
Okay.
For that part, you can use. Yeah, exactly. And we're not going to use it extensively. It's just to talk about what it is and how it exists and how you can use it. So don't worry about it.
Okay. So just for my clarity, Jupyter and Spyder are very different, right? Spyder would be something like RStudio, I'm guessing.
Yep. And Jupyter, yeah, they're very different. They'll do the same things. They'll run Python code.
So even if my Jupyter notebook doesn't work, I can still make do with Spyder.
Totally. Yeah.
Thanks.
Sorry? Yeah.
I enrolled for class, and so I want to get credit from
Right.
workshops. So what should I do?
Right. So later today, we haven't gotten there yet. We're gonna sort of write our own code to try and solve some tasks. At the end of each day, send me the code that you made during that time of the day, and then that'll serve to represent your coursework for the course.
So at the first part, the code I don't need to.
No, these are just like notes. Yeah, I think these aren't anything. I mean, I've got your name and role for participation, so I don't have it there. Cool. Yeah. Yeah.
On yours, you have it's all fitted,
Oh,
so
yeah.
all the text.
That's the first thing I'm going to talk about. Someone else had the same question.
Okay.
Yeah. Okay, great. So I think we're all back. So we'll pick up again. Now, I apologize. That's one of the, a couple people asked a very important question I try to get to, but it just slipped my mind. So many of you likely have text editor here screens where the text just keeps spanning far and far off to the side. I am so sorry. I forgot to tell you there's a way we can fix that so it doesn't do that. Go to your preferences for Python, for Spyder, and on Macs, you just click on Python, go to preferences. For PCs, I'm sorry, I'm blanking on where you find preferences. I think it's in a similar case as tools, possibly, or settings. And then from there, you have a list of all these different tabs that allow you to kind of customize the working experience you have with Spyder. If you go and click on editor, because you want to change something about how the editor interacts, and then go down, you'll find a wrap lines box that you can check, press apply, then OK. And now you should have all of the text wrapping enabled. Okay. So we're going to learn about writing our own functions. It's arguably a little early for us to be learning this, but it's a way for us to sort of get to introduce a little more practice on our own in terms of learning some of these things, practicing some of these things we're learning. And it's not hopefully too early to learn about functions because you can write these all the time. So functions, like the ones that are inherent in Python, the maximum function, the minimum function, the print function, we can write our own functions to use for future purposes. Maybe there's some procedure that you've been doing over and over and over and over and over again on some repeated data set that you have. And what you'd like to be able to do is not have to just keep highlighting the same block of code after changing a couple parts, the same parts, and running it for every time you ran the code, or sorry, ran the experiment. You'd like to just be able to call that code as if it were a function and run it just by typing the name of that function. We can do that. We can write our own functions, which kind of gets us to the broader act of programming in terms of putting all these complex tasks into one streamlined function. So in Python, functions have the following form. I have this all in quotes just to sort of denote what is part of this mock function here. Use the phrase def to define the function, and then there's a space, and then you have the function name, all as one continuous stream of letters, punctuation, what have you, no spaces involved there. And then parentheses, excuse me. And inside these parentheses, you list the names of the variables that will show up inside of that function that you'll then use for operations within the function. So I'm calling these parameter 1, parameter 2, in terms of the different parameters that are going to show up inside this function. And then you close the parentheses, and then you have a colon. And then when we press return, we now enter all of the code we would need, all the operations that happen within the function, and comments to help explain what that function does. And at the end of all of that code, we type a command return, space, and then whatever you want Python to return as a sort of result of your function. That's the general body layout of a function in Python. Let's now type one together. For our first function, we're going to write a function that will take as a parameter, suppose it's an integer or a float, it's going to take a number as a parameter, and then return 3 times the value of that parameter. So it's not a very fancy function, it's just doing math, multiplying things by 3, but allows us to at least kind of experiment with these few things. So we'll type def. Already that object, those letters are recognized by Python as special characters for defining a function, and then space, and then the name of the function, and we'll call it my first function. And that's also typeset in a different color, as Python is recognizing more of these parts for reserved for functions. Inside these parentheses, I'm going to type the phrase my parameter, close parentheses, and press, and then enter colon. And now when we hit return to break line break and go to the next line, now we're going to have, we'll notice Python automatically tab indents for this next block of code. So this is what I was talking about earlier about how Python uses white space to automatically organize your code and also eliminate you having to use more punctuation. Some languages you would enter more brackets or parentheses here to denote the body of this function. In Python, it's done it's all done automatically with white space. So I'm going to add a comment here inside of our function so we can practice these good habits together. So I use the pound symbol to denote code that won't be executed, comment. And right here, this is the inside of our first function. Space. Everything we type here is executed only when the function is called. So it's important to realize that things that are typed inside of functions are not executed when we run other things outside of the function. They're only run when we run the function itself. So for example, this my parameter variable isn't going to exist outside the use of this function. It's only going to exist within the use of this function. You'll notice there's no my parameter variable name in our variable explorer. So first thing with this function, let's add a print statement to the function for fun and to see that it runs. So the first thing this function will do, aside from running these comments that won't execute because they're comments, it'll hit this print function, and then it'll print the phrase I'm going to type, running my first function. Okay. Now we're going to use reassignment to change the value of my parameter by 3 times its old value, because that's the point of this function, is to multiply numbers by 3. So we'll take, we'll add another comment. It says, now change my parameter to 3 times its value. So I have a comment telling me, the reader of this function I just found, what this next part of the function is doing, in case I wasn't sure. We'll say my parameter, the variable, equals 3 times my parameter, the variable. And then now we'll use the return function, command, sorry, the return command. So I type return. Notice it's also automatically changed in font color. It's bolded and it's changed to orange, just as the DEF is. Those represent the beginning and end of the function. So now we're going to return the value of my parameter. Okay. So now we can run everything. We can run all the Python code in this cell, which is all this comments talking about functions, and then the code specific to my first function. So I'll press command, or sorry, I'll press control return. And then the output console is printed all of this Python code, which is okay, here we go. As before, we have def, my function, comments that showed up inside, and then the things that it does, and no output because we're not doing anything with the function. We're not using it. It's not generating output. We're just defining it. Now, functions aren't variables, so their names are going to show up in the variable explorer. That's honestly, I think, a bit of a downside with at least Spyder. Folks who use R or Studio, you may remember that like names of functions show up inside your variable explorer as well, your environment. Not so here. So you have to remember the names of the functions that you've defined. But really importantly, do notice the variable name, my parameter, has not been defined inside the variable explorer. We do use it inside the function. We use my parameter to represent the number we're going to feed to our function, and then the variable that we do operations on within my first function. But after the use of my first function, that variable name is gone. It's specific, it's local only to the function, my first function. It doesn't exist outside of the function itself. It doesn't exist in our variable explorer. So now let's try running our function with different inputs. Now we just type the name of the function, my first function, open parentheses. We know it now exists, that it did execute and compile because the tab completion in Spyder is kicking in and trying, oh, we recognize this, it is a function, it takes arguments, its argument is my parameter, you have to enter in a value for my parameter. Let's put in the value 5 inside those parentheses and press Control Return. And now we have in our console first the line of code representing us executing my first function with the entry 5. Here's that first print statement running my first function, which is doing what we said to do with that print command. And then next is the output, the value of 15, 3 times the input value of 5. Okay. Maybe you want to save the output from your function to a variable name. You don't want to just run it once and then have the output generated in the console and gone. You'd like to save it. We can do that. We'll use the variable name my number, set it equal to my first function, parentheses, pick another number. I'll pick 10 this time. So now we're assigning to the characters my number as a variable name now, what will be the output of running the function, my first function. So now if I press Command Control Return, now there's no output generated. The print statement is still done because that's really getting us more in towards what prints will do. They'll just always print something regardless of whether we have output or not. But notice we don't have what would be 3 times 10 or 30. We don't have that 30 output like we did before. It's just blank. That's because we've assigned the value to the variable my number instead. So we can go up into the variable explorer and we'll find the variable name my number has been assigned the value of 30 as the output from running our first function. This isn't really pertinent to anything we're doing, but I just realized someone might ask, so I'll show it's okay. If you wanted to, you could run your function within itself. So I can type my first function, parentheses, my first function, parentheses, 10, and that should execute. Essentially, we put 10, and inside the input for the first running of our first function, the output would be 30, and then that value of 30 should serve as input for the next execution of my first function. So then the output for that should be 90. Press Command Return, and that does indeed work. We have now 90 as this output from this nested use of this function. Okay. Any questions with writing functions? It's a very, very basic example. The activities we do later today will be practicing writing our own functions, but now's a good chance for questions on them. Okay. we're almost to the first activity. Before we can do that, we need to get a little more experience working with text and working with strings. So okay, this comment also really extends to what's going to be happening tomorrow as well. A lot of the examples, because of how the Python workshops are broken up, we're not going to really analyze two-dimensional data. We're just going to analyze one-dimensional data in the form of thinking about DNA sequences and the sequences of nucleotide letters, A, T, G, C, there. Like I said, I didn't say this. I don't actually sequence myself. A lot of what we're going to be doing is kind of geared towards that direction. This data may not be your thing. You may not actually work in DNA sequencing at all, which is fine. Hey, we invite you to come along for this part of the workshop, the rest of it. As you're still going to learn a lot of really vital programming concepts, we can still cover many very transferable ideas, focusing just on those types of applications, but they still transcend many other ideas. Let's see, quotation marks. Good, right, here. So now we'll do an example of, as was the question from earlier, does it matter what types of quotation marks we use? It does. So we'll just real quick show how this is an issue. Whether you use single or double quotes, define a string using single quotes. So I'll just make a example. I'll use the phrase example string as a variable name for an example string. And the example will be, in single quotes, cheese. And there's no issues there. I can execute that block of code. I have a variable name, example string, and its value is there, cheese, off on the value. I can do this with double quotes as well. It's not a problem. Call it second example. And in double quotes, I'll put Parmesan. And that's also not an issue. But what if we mix single and double quotes? So now with this third example, the name of the variable name will be third example. And I'm going to start with a single quote, and I'm going to type sheep's milk and make it possessive so that I use an apostrophe in the middle of the string. So I type sheep's milk. Uh-oh, you see what happened? The font coloring changes halfway through when the possessive apostrophe for sheep's gets read as the end single quote for a string. And then Python gets confused when I type more characters afterward, followed by another single quote. This becomes an issue. Oh yeah, this should be, we'll keep this down here. Whereas if we used double quotes, this wouldn't have come up. Double quotes are fine in this instance. So, you know, your two rules for this are either never type apostrophes and don't use possessive forms. If you're doing text analysis, so I don't know how many folks in here are from more of the social sciences, but there's been a really pretty cool growth in the social sciences fields of analyzing texts using programming techniques and doing like text analysis. So how many different types of words of, you know, how many unique words show up in different hip hop songs? That's the best example I have at the moment on top of my head. We're analyzing uniqueness of words in like Shakespearean works versus other plays, not by Shakespeare. You know, in these examples, you might be actually really caring about apostrophes showing up because they show up in your data in that case, since you're looking at text. So just an important caveat, if you're worried about apostrophes being there, then be using double quotes when you're defining strings. If it doesn't matter, then single.
Double quote in your string and singles to make sure.
Oof. Yeah, it looks like it's okay. If there's a double quote inside the string, can you use single quotes outside? And since I don't just know the answer, I'm just testing, and it looks like it compiles. I don't get any errors, so I think that's okay. You can also add what are called escape slashes if you really need to in some of these instances. Yeah, so if I use a backslash in front of this apostrophe, then what's happening is that combination of backslash and apostrophe are read as a declaration of Python. Don't read this following apostrophe as a string quote, read it as part of this text, which I think is the more formal approach for dealing with special characters inside of strings. Yeah, in that case, that compiles okay. For the examples we'll be working with, this won't be an issue we have to deal with, but it is in general something that can arise depending on the type of strings you're analyzing. I promise I won't hand you any data that has possessive apostrophes in it just to mess with you and keep you on your toes. Okay. Logicals, inclusions, and then some basic functions and strings, and then we make functions. So we can use the in function and the not in function to search for the presence of one string or a motif, subsequence, inside of other strings, motifs, or larger sequences. So for example, try asking Python if the string, capital ATA, is contained in the larger string, TATA, TATA. So you type in double quotes, ATA, and then I'm typing the letters in. Those get recognized as a special function, and then now in quotes, letters TATA, TATA. And if I press Control Return, Python says yes, the subsequence of letters ATA are in the larger sequence of letters TATA, TATA. And it's just returned as a logical, a true statement. You could ask about not in. So is a sequence or subsequence of letters not in another sequence or subsequence? So we'll try asking Python if the string banana is not in the larger string fruit bowl, which should be true. Banana is not in fruit bowl in these string instances. In the literal interpretive sense that the characters BANA and A are not inside of if RUIT space BOW. We can also merge strings together or concatenate them using the addition operator. So for example, I can take the letters AC and type plus them in the letters TG when AC and TG are in quotes. And then if I press Control Return, then the output here is now ACTG. They've all been squished together and merged into one singular string with no spaces between them. We can also use the multiplication symbol to repeat subsequences or motifs. So, excuse me, I can type 5 times the letters AT in quotes. Notice the 5 and the multiplication symbol are not in quotes, just the letters that I want repeated are in quotes. I press Control Return. Then Python prints out the sequence AT, 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 or the sequence AT repeated 5 times and all merge into one singular string. So these can be some useful functional manipulations for strings in Python. Strings also have functions or methods inherent to them. Interested in seeing a list of these different methods, you can type dir parentheses and then type the name of the string inside. So I'll use up here what I defined my example string from before. I press Control Return, and now in the console, Python has printed out a list of all of the functions that are defined specifically just for analyzing or interacting with strings in Python. We're going to focus on these ones that aren't accompanied with double underscores. So there's capitalize, case hold, center, count, and code ends with find, format, index. There's many. We'll only use very few, but they're called inherent methods associated with the string type. To use these are different from functions like max or min, where you type the name of the function and put the thing inside of it. To use these, we type the name of the variable, example string, followed by a period, followed by the name of these functions we want to use. And then a parentheses, which we'll explain. So, for example, we're going to use the uppercase function, which sets all of the alphabet values in the string to be uppercase values. So I take the variable name, example string, type period, and I'm going to type upper, but you can see autocomplete's already given me the list of functions or methods that are inherent to strings, and I can scroll along here and search them if I want. But if I know I'm looking for upper, I can just keep typing upper. And then I type open close parentheses, and then press Control Return. So since example string, that variable name was for the string cheese, all in lowercase. When I use the upper function on example string, the output is just all capitalized cheese. The parentheses here, these are used because occasionally we might use one of these functions that only focuses on a certain character. If we're not doing that, then it's just blank, but we still have to include the parentheses because that's part of the function name. It's frustrating, it's a little annoying, but it comes into play. Oh, we'll see in just a moment. Excuse me. We can do the same thing with, there's a lower function if you want to make all the letters in a string lowercase instead of uppercase. Then you do the same thing we did before, only you type dot lower instead of dot upper. And it would force all of the letters to be lowercase. We can also count the number of occurrences of a particular individual character or combination of characters using the dot count function. So for example, the word cheese, the letter E appears 3 times. So we're going to use this count function to count the number of occurrences of the letter E. So I'll type the name of the string, example string, dot count for the count function. And now inside these parentheses, I'm going to type in quotes the letter E. Right, so we're using we're going to use the count function or a method on the variable represented by example string, so cheese, and then we specifically want to count for the number of instances of lowercase e's in the word cheese. And I said lowercase because that is what we're asking for. We're asking for instances of lowercase e, since that's what we typed inside the parentheses. So let's try Control Return, and now the output I have is 3. There are 3 singular lowercase e's there. And it will catch whether you type things differently. So if I do a capital E, press Control Return, I get 0 because it's not a capitalized word that I used. If I do double E, it will only find all double E's. So we have one double E. It won't parse individual E's. as per that. Yeah. Okay. A couple more functions. We can ask Python to find the first index corresponding to the location of elements in a string. So we can type example string and then type dot find, the name of this function. Then inside of the parentheses in quotes, again, single E, press Control return, and the number we get 2 tells us essentially which location, where along the word, as we count our way along letters, we encounter the first E. To really delve into that some more, we need to talk more about what's called indexing, which we're not doing until tomorrow. So I'm just gonna, that function's there, we'll use it again later. Starts with is one we will use some more today though. So here, example, string, and the function starts with. We can have we can have Python tell us whether or not the string starts with a certain sequence or subsequence of strings or characters. So in this case, to see that it works, we'll use the character C, lowercase c, press Control return, and the output is true. Yes, indeed, example string starts with C, cheese, as we spelled it, starts with C. I could also make this CH, press Control return, and that is true. But if I made it a C with a capital H and press Control return, then I get a false, because the way we spelled cheese was all lowercase. Yes, question?
I don't think I understood fine. Because that's the third character in cheese.
Yeah, okay, yes, great question. So we'll, a big part of tomorrow is going to be focusing on what's called indexing, or these numerical representations of the orderings of elements in strings. But we'll address this because it is odd. So, right, you might think, okay, here's 1, here's 2, here's 3, here's 4, here's 5, and here's 6. And if you work in R, this should be what you're thinking. However, in Python, it's called a zero-indexed language. In other words, Python doesn't start counting at 1. Python starts counting at 0. So some languages will say, do this. Python counts from 0 first, so 0, 1, 2, 3, 4, 5. So that is why E, the first E, shows up in the 2 spot. It's annoying. Okay. For example, what if we did C here instead of E in this example.string.find? We should have a 0. Good, yeah. So C shows up as the first or 0th object. But yeah, we'll get lots more practice with that aspect tomorrow. Okay, last function, and then we write more of our own functions, and we finally write some of our own code separately from this talk and follow approach. So length, we can ask for the length of a string. How many characters make up that string? Using the length function, which is just len. You can ask for the length of more than just strings though, so this isn't the type of function that's used by writing the name of the variable with a period and the name of the function. This is its own separate function, kind of like maximum, minimum, absolute value. So here it's len, parentheses, example string, close parentheses, Control return, and it tells us that there are 6 letters in this, well, not letter, just 6 things inside of the string representing the 6 letters of cheese. Okay. All right, any questions from folks on these different functions, most of which are specifically for strings and analyzing strings?
Then could also include spaces.
Yes, Yeah, so if it was 2 words, if it was, if example string was Parmesan space cheese, then the space would be counted as well. Yeah, as a character. Apostrophes as well. Apostrophes would be counted as a character. Okay, any other questions? All right, so we're going to put a lot of this together to build a function. And also, oops. Okay, so we're going to make a more useful function. This new function will calculate what's called the GC content of a string or a sequence. So imagine now we're not playing with all of these fun cheese-themed strings. Now it's DNA sequence strings, so they only consist of the letters A, T, G, C. For convenience, you should assume they're always capitalized, so you don't have to worry about changing cases. But if you want the extra challenge, you can try using case changers. But the main thing your function should do is count the occurrences of G, the letter G in a sequence, and add that to the number of occurrences of C in the sequence, and then divide the sum of those numbers by the total length of the sequence and return that result. So you can think of this as, here are the instructions of what this function should do. Separately, you have, right, we have that example of what a function looks like, how to write one, and then now we have all of these examples of string functions we can use to try and do these different things. Now, the task for the next 15, 20 minutes or so is going to be write this function. However, for those of you who want to be in this survey still, which would be great, what we're going to do is pair you off with another person, and you'll work on this together, but you're only going to use one computer. And the idea is that one of you will be doing the actual typing, and the other one will be helping kind of plan and strategize and think about what's being done while the other one's doing the typing. It's called a driver and navigator approach. And this, I'm not super creative. I'm not the one who came up with this. People have been doing this in programming for a long time. It actually comes from, how many of you have seen Silicon Valley, the show, and they have those boards with all the sticky tabs and they're doing all the code development? Okay, it's a technique from the software development world that people have used to try and help generate code, we'll say. So for those of you participating, you should all have one of these little tags, a little piece of paper. It's either got an N on it or a D on it that indicates whether you are a navigator or a driver for your pair. If you can find sitting near you someone who has an opposite labeled tag, they will be your partner for the activity. And the person with the D will do the typing, and the person with the N will do the navigating. So go ahead, please take a moment to find a neighboring partner. If you don't have a tag, I can bring you one. Work is also choose one type for taken.
You give me an idea, I'll give you the idea. I got it. Okay, cool. Oh, that's perfect. Are you still working?
Do you want to know the numbers?
Oh, you already did it? Oh. We can start off with right now.
Okay, great. So as I mentioned, right, one of you is doing the typing, the other one is not doing the typing. That's the only rule. And don't worry, for the next one, we'll switch, so you'll both get a chance typing and navigating. Okay. That being said, I'm going to go around. I'm here. I'll help answer any questions you have as you're working on this. But the point is, you have lots of notes from what we've done today as we'll go through. Prior examples, I promise you have everything you need to do this.
always kind of name it as the other is, right?
Or actually,
Yeah, because you have to define things. Yeah, like, you give me the idea. You can name it. But you see, yeah. Okay. And then,
Sure.
oh, you do it inside. Yep. I personally do it as creative authority. Because like if you do that together, that would be like a game they would write. So we're gonna so you get kind of like put some parameters.
I think there is
G, num, G, and no, give me an idea.
Yeah.
I just think that if you stack them, yeah, so run. But if you put them together, they actually look so like yeah. So if like you have A, G, A, so G, they don't find G equals to. Right. So that's why that's what I'm trying to say.
Yeah. So instead of like counting the number
And then you should. Yeah. You can.
But then it doesn't get it.
Yeah. Because like you count the number of C, you count the number of C. You. Right. So you have to like also try to hold it.
So I think that would work.
But you have to divide the whole thing. So you have to yeah, so then you have to name that.
Like the count is like mass.
Something like that. Yeah.
Yeah. It's 7.
By the way, my name's Sean. I was going to say my name. Yeah, so now we just need enters. But you can eventually maybe have lowercase letters as well. So you have to think settings for Yes.
So the results are.
Yeah. So if you do this, but it doesn't. Yeah. Now it doesn't look nice for the day.
It's because of your
Yeah. School district, okay, cool. Very different. So here is the data.
That's right.
Oh, you're doing research. Okay.
I think either is.
Right.
Yeah.
Because I think you like
The first one.
I had to see that story.
Wait, no, yeah, so we have 4. No.
So just choose the ones, right?
Oh, I see what happened. So in this one, like the first one, yeah, so it's like somewhere gets somewhere. So we should capitalize.
Something, but not quite.
And then once we capitalize, we should be
Oh, got it.
good.
They're always like, I don't want to I didn't want to do piano, I want to do guitar. I'm like, piano first, then do guitar.
So I think
Oh, right, so we're,
that should be
we're
everything.
going to work. So the functions are where you're going to.
Oh, okay. So this has to be set as a parameter one.
Not twice. So
Yeah.
everything inside the function should be presented over.
Oh, yeah. Nice, like.
It was probably trying to force everything over that way too, as you're pressing return.
You did. And like that portion. I was like that.
Yes, exactly. Good.
No, I didn't.
Yeah, so sometimes.
Oh, no, I was trying.
We have.
I don't want to use that mouse.
Yeah, that's the way I want it. Yeah.
So.
Well, we don't have any of these.
I'm not like.
We don't have that.
Like one thing is like.
Terrific. That's great.
I had a friend who got
So you in the chemistry.
So I'm
whatever degree she got that in Korea.
Oh, because this is great.
Oh, okay, that's not bad.
Oh, got it.
So our
just the it's basically like
So like the bioscience, there's 10 different layers in there. Really? Oh,
Oh, there. That's what you
yeah, I have no idea.
yeah, so it's yeah.
Great. Okay, so we're going to come back together. Walking around this look like this went very well for groups. So we're going to all start walking through how I'm about typing this together, and then as questions arise, as they percolate, we can address them. It looks like Python quit unexpectedly while I was gone, which is fine. So we'll get rid of it. Okay. So. Where do I want to start? So one thing I want to try and quick highlight, as a lot of you are brainstorming how to do this, which is great, and you're generating ideas, and one thing that can be really helpful when you're typing code is to type what's called pseudocode. And either that's something that you type or it's something that you actually write with like pencil and pen on paper on the side, which is like a rough draft version of what the code will be, what it's going to do, without worrying about the details of where the parentheses go, where the white space is, how to return the exact names of the functions. You're just sort of writing down the instructions as if it's like a recipe or a for cooking, a recipe for cooking. So for example, I'm going to type the instructions. Input is a sequence here, sorry, pound example pseudocode. And say input is a sequence, and then first count occurrences of G in input. And then I'm going to save that count as a new temporary variable so I can do something with it later. Some of you didn't do that, that's fine. You might have had everything work in one line, which if it works, it's great, that's fine. That might run faster in some instances. But then it might also be harder to read and parse what your code is doing. So there's sort of all these trade-offs between how many in-between steps you might use. But for the purposes of being very pedantic, I'm going to type everything. So first count occurrences of G in input, and then save to variable. Second, count occurrences of C in input, and save to variable. Third, add counts, save to variable. Fourth, divide sum by length of input, save to variable. And then fifth will be return, we'll call it a quotient, I guess that's what it is, as output. So I have now this pseudocode, the sketch of what my function is going to do. Then now I'm going to go fill in all the technical parts. Now that I have this plan for what I'm doing. So I start by defining the name of this function. I'm calling it GC content. And then I have to make a temporary parameter name. I'm going to call it SEQ. That just represents any variable sequence that I could use as input into this function. I'll type colon and then return. And I'm going to start typing the technical versions of the pseudocode descriptions that I made above. So my first step is count occurrences of G in input, save to variable. So I'll type first lowercase g capital count equals. So that's me saving to the variable name G count will be the number of occurrences of G in the sequence SEQ. So as I do this, I'm going to do one more thing separately outside of this function in a separate cell. I'm going to define the variable seq as an actual string I can experiment with, so that while I'm doing this, I can test the different parts of the code that I'm writing. So I'll write seq equals GATC, or GACT, and press Control Return. So now, even though in this function where seq is this temporary variable that we'll use inside the function, as I'm working with it inside the function, I actually have it's defined elsewhere, so I can experiment with in real time as I write this function. So gcount will be an operation on seq. I want to actually count the occurrences of the capital letter G. So I'm going to type seq, and since seek has been defined and exists in the variable explorer, when I type seq dot, oh no, tab complete, that's too bad. Okay, well, what's the function I want to use if I want to count the number of occurrences of a thing inside of a string? Count. It's one of the ones that is helpful, is just tell how many times does a certain letter appear. I have count, parentheses, quotes, capital G. And I should be able to, if I wanted to, I can just highlight seq.count. I'm going to go to the actual terminal, console off to the right, and paste that line of code and press return and see that it works. Seek.count for letters of G. G shows up once in seq, where we defined seq as GACT all the way down there. So this is good. This will count from the number of times G shows up and save it to the variable name gcount. Now, second, we'll do the same thing, but for C. So I'm going to highlight this command, paste it. So I have here this tab. I'm going to rename it to ccount, and here equals seek.count in quotes capital C. So now I'll count the number of times the letter capital C appears in the input parameter seq. Okay, now third, we're going to add the counts. So I'm going to make a new name, call it gcount. It will be equal to my value for gcount plus my value for ccount. And then as my fourth, I'm going to divide the result from my third line. I'm going to divide that by the length of the input in total and save that to another variable. So I'll call this GC fraction is equal to GC count divided by, right, so this is the sum of those values divided by the length of the input sequence, len, for the length function, and then seq for that input sequence.
Can we do the division in the third line itself?
Yes. Yep, you could do, question is, could you do the division in the third line itself? You totally could. We could put parentheses in here and then wrap the division around that. And then I don't need, oops, I don't need that line of code at all. Absolutely. Like I mentioned, I'm just putting all of the in-between steps in here to make it super clear the different steps we're taking. Some folks do all of this just in one line, which is fine. You could also do that. You could even do it without the in-between lines, and you just put it all in the return statement itself. You can put math in the return statement, which is also fine. Okay, so finally then we return GC fraction, and that should be the end of defining our function. No errors were generated when we compiled the function, which is great. Now let's test it out. GC content is the name of our function, and seek. Okay, so this is, a lot of folks are caught up. A lot of you wrote great functions, and then when you went to run it, you didn't have quotes around your test strings. You just wrote combinations of capital letters. It's important to remember these are assumed to be strings, so we have to make sure we put in here the single quotes to define the strings. Now I can type in any combination of these 4 letters I want. And I can try running my function, GC content, and I should get a fractional value representing the proportion of letters G and C in the string. any questions from folks on aspects of things they did differently, problems they ran into, would it work this way or that way, kind of things. I saw a lot of perfectly fine ways to do this, and they were all different. Not a single group wrote this the same way, which is programming. That's how it goes. You? No? Yes?
I have a question. So when you count something, you can use sequencing dot count.
Yep.
Why not? Why can't we do as sequencing dot length to get the length? You have to do the length.
Or excuse me. So, were you asking why count and length do different things?
Can you do counting the length by just sequencing dot length parentheses?
No. So the length function is just, it's not how it's defined in Python.
So like the count function performs similarly, just like the length function, right?
Does the
In terms of the format.
You can do the same thing with count, you like count and then first variable C.
Right. But why not like the length function can also have similar expression like that?
I just don't think it's written that way.
Yeah, it sounds like you're just like, why is length len parentheses the name of the variable and count, name of the variable dot count.
Right.
Yeah, because we can use length on more than just strings. So count is in the broader sense of the word, count's a function.
Right.
But more accurately, it's a method. And it's a method specific to strings. So for strings, we can count the number of instances of a certain thing in the string.
Right.
But you might be interested in the length of a vector, or the length of a file of folders, or a folder of files.
So the function has to be specific to the object like string.
Yep.
Then you can do object dots the function.
Yep. Exactly.
Okay.
Yeah. Yeah. So you'll oftentimes, in looking up things about Python online, they'll talk about methods.
Right.
And methods are still functions. It's just that they're functions specific to different types of objects.
Right.
In this case, strings. Yeah. That's the only difference between them, and why they're formatted that way, so that you keep the difference between them clear.
Okay. Thanks.
Yeah. Okay. Other questions? We're going to learn. Excuse me. We're going to learn about if-else statements, logicals, how to do these conditions, and then we'll come back and do an activity again to finish out the day. So, by the way, that was great. The pairing, thank you everyone, that was perfect. We'll do it like that every single time, and it'll be wonderful. So if-else statements, or the trues and the falses. So we're gonna get into the real utility of trues and falses, or conditionals right now. And it comes in with using if-else statements. So if-else statements, these are statements you tell Python to do something if a certain condition is true, and if the condition is false, then we do something else. So there's the if-else idea. If this is true, do that. If this is not true, do that other thing I'm about to tell you to do. They're extremely valuable statements to know how to write. And we're going to try writing one right now. We're going to write an if-else statement that prints a string depending on whether one number is greater than another number. So to do that, we'll first define a variable to represent our first number. I'll call this my number, set it equal to 10, and press Control Return. So now we'll write the if-else statement. If-else statements always start with the phrase if, and it shows up in orange as a recognized thing within Python. So now the question is going to be if my number is greater than or equal to, so we use the greater than wedge symbol and an equal sign to represent greater or equal to. I'm going to compare the value of my number to the number 4. So if 10 is larger or equal to 4, we're going to tell Python to do something. So we end the if statement with a colon, and then you press return. And now it's automatically indented, which is telling you that now we're in the body of the if statement. So here's the code that will be executed if the above statement is true, if 10 is greater than 4. The idea is we're going to print the statement in string, in quotes, my number is greater than 4. Okay. However, my number might not be greater than 4. It might be less than 4. So now we're going to write the else statement. So I'm done with what I want to be executed if my number is greater than 4. Now I want to define what we do in the other scenario. So I delete. So now the cursor is back aligned with the if, with the I. And here I'm going to type else. So now I'm typing the second condition. No, sorry, that's if, else, if. We'll get there later. Sorry, else. We simply just say else, colon, return. So here's what we do if that first statement is not true. We're going to have the print statement, and in quotes, my number is less than 4, close quotes, close parentheses. So again, highlighting these parts, we have these sort of 3 different sections here. The first section is what is the condition we want to check for? It's preceded by an if statement. So if this condition is true, then we'll do whatever shows up immediately afterward as this first print section. If this statement is not true, then we come to the else section. That's the if-else idea. So if true, do the first print statement, else, if not true, do the second print statement. You use if-elses if you're doing cases where there's only 2 possible scenarios. We don't need a third scenario, so we don't have to explain the condition for the second scenario here. So let's try running this. Press Control Return. And what was printed in the end was simply the phrase, my number is greater than 4.
But it's not, because you have greater than or equal in the operator, greater than in the message.
Fair, sorry. I removed the equal sign, yeah, this is good. Okay, so being very specific, because I use greater than or equal to in defining this expression, point was made, we should be more careful about what we're typing here to state, which is true, because I could have used 10 here to compare against instead of 4, and then that would change how this works. So no, that's good, thank you. We'll remove the equal sign and just make this be strictly greater than, and not a relaxed greater than. Okay.
Is there any ending of statements?
White space. Yeah, the ending of the different blocks comes when you move the indentation and remove it away, yeah. It takes a little getting used to, and definitely feels odd if you've programmed before, where you might be used to having the different parentheses closing the statements. Okay. Let's see. All right, you have comment on formatting. So now, what if you have a third condition? So if elif else statements are what we're looking at, where this elif represents the possibility of a third scenario, what we've done is we've replaced that original else with another if. So that's why it's elif. In this case, it's not elif as in elif not the number. It's a contraction of the phrase else and if for a new if. Right, so you might have multiple conditional scenarios, not just one true or false case, but maybe you have a third case. So we use the elif statement. So we'll use this for a scenario greater, less than, or equal to in this case. So using the same my number as before, we'll start with instead if my number we defined is greater than 10, colon, we'll do something. We'll print the statement. My number is greater than 10. and then backspace, because now we're going to set up the elif command. Else if, or just elif. Now we write the new condition, because it might not just be that it's greater or less than 10, it could be exactly equal to 10. So now we have elif my number double equal sign 10. Then we'll now run the print command. My number is exactly equal to 10. And then finally we type else colon return. And now this is what's run if neither of the above conditions are true. So if everything we've said, check for this condition false, check for this next condition is false. If those are all false, then we come to the final else statement. And this is what will be run end of the day. Print quotes, my number is less than 10. You can run this block, press Control return. And in my console output, there is all of that logical that if, elif, else statement that I wrote. And then finally the output phrase, my number is exactly equal to 10, because my number, the variable, was defined to be exactly equal to 10. This doesn't have to be, you don't just have to use the elif command for these 3 scenario cases. You could have 20 scenarios that you're testing through, and you just keep typing elif new condition, what do you do? Elif new condition, what do you do? It's you could use it ad nauseum. Any questions on if else and if elif else statements?
Not sure.
Yes.
Maybe I missed this. Could you just write it out else if, or would there be an error?
Good question. Let's see. I think you can write out else if also. And syntax error, invalid syntax. And the caret is under that if. It doesn't like else ifs. Yeah. Elif. Thank you. Great question. Any other questions? Okay. Then we will go to writing our third and final function for the day. Similar ideas what we've been doing, only now we're going to incorporate these if-else statements into the body of a function. The instructions for this function should again take any input sequence of ATGC, search for that sequence end. Here's your key. If the sequence starts with ATC, got too excited, excuse me. If the sequence starts with ATC, do something. Print the T content of the sequence, as we did with the GC content earlier. If the sequence starts with AGC, do something else. Prints the phrase starting with AGC, and also print the number of times G appears, but only if it does not follow the letter A. Add a slight caveat. How does G appear specifically in terms of other letters? And then finally, if the sequence starts with neither ATC or AGC, then print starting with neither ATC or AGC. So those are your conditions and tasks to be performed based on what the string looks like. Again, you have all the functions you need for doing this. Now just time to be creative and try experimenting and making this function. We'll just spend the rest of today writing this. And then tomorrow we'll come back and start with going over together how this works, or how we did this, writing this function. So please pair up again with your same partners from before, but now switch roles. So whoever was typing before will now be not typing this time, and whoever is not typing before will now be typing this time. And then again, I'll be going around helping field any questions you might have as you're working on this task. And then I think we still have, yeah, this is working, great.
First is starts with an AC. Is second is starts with an AC.
I think that fits. Okay.
Yeah.
Here.
Yep. Yeah. So the return would be
Oh, no, I have another.
It is the final questions. Or I can just say, it doesn't start with that.
Yeah, because
it's dawn starts.
Oh, that is.
which one do you have?
Yeah, no.
Maybe because the did yours come out? Like when you typed it, it came out. So only like the numbers. I guess because I haven't defined it as a string. And then if it does, oh, we return.
If there is,
No, I'm right.
Yeah. But I wonder if it's also
Yeah, I mean, I can do it because it.
Okay, I'll just not do too much. I can finish all of
and then I multiplied it by
and that's actually so I did like count the number of yeah, and then my first grade is
You can just put it and see.
yeah, that's the difference. Something like that.
So I think we're trying to
I think well, I was just looking because so
Okay, so I missed something. So
Also,
Oh, yeah.
well, you can correct the indentation too.
statement
No, no, I mean, indentation on
starts with this one.
right. Yeah. More. So yeah, that's right.
You can just name it whatever. Okay. Oh, you don't need.
Oh, yeah.
You can do more altitude.
It's a break.
Yeah.
Oh, no, this is good.
Yeah. We can do more altitude.
But you can, if you want to make a variable.
Do you want to return to ended? Even if you don't return it.
I've done this now.
Right.
Do you agree?
So, AGC. Yeah. Okay, so you have, I think there's
Okay,
so,
it definitely still wouldn't have AG.
You can say like
And then
Elsie starting with
general, yes. So, spiritual.
And then so one I defined as like the other two and
because I haven't even started anything. So
age.
Okay, so maybe that's print. There's gonna be a number. Yeah. Fine.
I just feel like the messaging using string is letters plus this number.
Because I can still have that.
Like this new text has sort of say string starting with AGC. And then this number, right, number of G's, that would be AGC. So maybe we define each of those.
Right under the Elif, I have the other ifs, right? So like I don't go to the end, but it has to be end of this. Because like it still has to check, right? It's
And then it'll only have one variable.
then I can do the other.
For me, I will. I do. I would go to like experimental.
There's a couple of options.
Like you can either follow T or you can follow C.
So
I think I would rather just combine things, right? Like
Since we're only applying this.
if we like C.
Or like I think like just what the quickest and dirtiest is. It's just
You can like one
Like right.
one and then there's also
this
small.
is like one wait, actually this time
I know it just goes with these.
Yeah, I think I could. That
So what is it?
It's just like each something, and then under that each, and make a whole. And I don't know everything.
So I think yeah, because You give it out.
Even if they're large, there's a G, you also give it addition. You also give
So, are we looking at clearsing
or C. So basically, looking for any like two letters
So then from those two letter sequences, that's what we're doing. So you're counting.
You're on counting
Yeah,
individual.
that's awesome.
That makes sense, but what if it's G?
So G is also counted. So like, so
It gives you the sort of the nice thing about sometimes people trying to identify and tells you the type error and then where it changes error.
whatever it starts with, like say it's like H, so you're typing
Yeah. So either it's telling you there's something wrong that is there or something wrong that should be there.
like because it's just
Because it stays doesn't not follow.
Yeah.
It's not sequence of
yeah. So the only problem with it is
So you can try it for different different cases. File. Good question. Yeah. So how can you check to make sure this G when it shows here only shows up in that way? Yeah. Right, so we're saying it's this area that you see. And then is this part the number times G appears? Yeah. Right.
That one's just
Yep.
that same
It's not. Yeah, so it is not it. Maybe there's a few ways.
yeah.
Yeah. For its intention. Yeah.
And then, so, with the nice function.
It's going for you too.
I think it's fine. So I guess like my first sense is just define because this would like
Good.
like if you have
Compare
a
and see what it's
like you're on the first like 1, 2 is 1, 1, 2, 3 is 1.
And
Like
so
you wouldn't like see.
why here? Okay, so if
I
we say
like,
that
so if it's like a G is not
Okay.
like
so if that one is true.
Right. Sure.
So you know there's a.
Because you're looking to see what comes before that.
So
Sure.
that gives you a Boolean.
Sounds like it.
So you can compare the Boolean.
Great.
Boolean.
Like an example sequence.
Excellent.
Another question about defining functions. They don't always have to return something at the end. Is that part of the skeleton of the function?
Return at the end. Yeah.
So if you don't have anything that you're wanting to return, you still write return.
Yes.
Yeah, because it helps indicate function is over. Yeah. Yeah, and that's a good question because we have these if else's inside of this function.
Right.
So we'll experiment with some different ways you can have these logicals and returns.
I got another question. I think it's more about the spacing. Why does the return go all the way back, like left? Like, what's the thing that-
Don't know. Style.
It just looks funny.
Yeah. Yeah. I think the idea is everything that comes back in line with that D is meant to be outside of the function finally.
Oh, got it.
And so if the return was there, then it might be kind of just is this inside or outside of the function? Even though since it's returned, it's not. But it's just the same thing. Yeah.
Yeah, that's harder.
So yeah.
Yeah, I tried to.
Like everything I've done is
So.
Yeah, I think
as you're typing it saves, and then like I think it does the same thing. So the asterisk. Yeah.
So this one and the one previously. Yeah, the two functions. Then we'll start with values.
But I did that.
On this one, no matter what we do with the ABC, we need to figure out how to make it print this, not in this form. Parentheses. So it's good enough for this, but.
Okay. Is it just because it's
Oh, I see, like aesthetics, yeah. Yeah. Oh, yeah. Yeah. Is there a way to do it? So what you want something that will be the text that never changes, followed by a number that can change. Yeah. It's you need a function we don't have yet. Okay. So.
Sorry.
Otherwise, it works. Yeah. Those are the cases. Yeah. Great. Perfect. Thank you.
Oh, because I think.
Sure.
That's like.
Nice work with you.
Oh. Oh, no, like the.
Oh, okay.
Yeah. It's okay. I sort of usually do okay, let's try.
Is it a variable name?
Cool.
Yeah. Well, to be fair, technically, 4:30, past 4:30, we're done. But yeah, so especially, yes.
Oh, I mean, like, you can do that. So where is
The next one, which is you want to
scan up here? Oh, because that one, like, it will become true, but you don't want it.
and then this.
I see.
It gives it right. And then instead of like C2 in both places, you get to plus instead.
But, so ABCA,
Yeah.
I mean, okay,
Anyway, the first one seems correct, right?
And then the last thing that we need to do is make an else at the very end. So we have to do it again, and that's it. And that else. And then, oh wait, actually we don't, I made this mistake too. Actually, we don't have anything after else. So okay, if anything else happens, if it doesn't start with or AG, we hit enter. Oh no, just and then it should tab, and then we'll do print starting with neither A, T, C, or
We want the number of times G appears. But only if G does not follow letter A.
or H.
Between which one is A?
And then or parentheses and
Well, so what if it's longer than 4 letters?
all the things.
Because it's a case on letter. So how many G's would we count?
I think you just need to like
How
add
many
all
of those
this
G's
one
don't
so
come
that it's
after the
yeah, because I think it should be on the same sort of line or whatever.
Oh, no, sorry. Yeah, it was meant to be like, does the G immediately follow letter A or C or G?
Oh, yeah, sure. We'll do print
Sorry.
first.
Not clear as fuck. But
And then
I'm sure you get it.
parentheses there.
So that's in general.
How's it going?
And then now we can do this for all three of them. Like this three. Oh, thank you. I'm gonna have errors. But then see how we did like C3. I think if we go underneath that and then we take a C3, C2, and then C3.
Sure.
Starting see if it works.
Okay, so, I think one, so you have, else if the start, now checking here, you have a new if statement. If
Oh, it printed out all the
starts
things,
with
so
AG,
C3, that's the proportion of T. And 5 is
equals, trying double equals. I think I know what you're trying to do. I just don't know if it will work enough, but I know domain is not right.
Thank you. I was doing like the
You
whole
call
time.
it after
Like you
this,
said, I couldn't figure out.
well, yeah, but call it. Yeah, the stack.
Last semester, I
Yeah.
teamed, and mostly I was like pissed off enough that I was like cheating. And it was so funny because I had some
Maybe, I'm not sure.
Allie,
You should have done that. So,
Neha? Okay. Yes.
one more column at the end of the list. Yep.
See, everyone in my program is like way smarter than me about all this, so that's why I'm like,
Okay.
I need to catch up.
It compiles. It may or may not be right. I don't know.
Yeah,
Right.
everyone else.
So
I
what
think
you have errors with the grammar of the syntax that we fixed, but it doesn't necessarily mean that it's doing the test.
Oh my god.
Yep, exactly.
Yeah, see, here, actually, you can put it in that way. Yeah, so they have no training in fundamental genetics. Like,
So in order to return
computation.
something, you have to use
And
pass.
all the training.
You mean pass is the actual phrase pass?
Yeah.
No, I think it's trying to just type, you have nothing after return. And it just doesn't return anything. Yeah.
I don't know, we
Give
had
me
a
errors.
psychiatric
Did it?
clinician in
Yes.
my old lab.
Syntax errors, and then I looked it up. They said I used tabs.
After return. Oh, interesting.
The other thing, so some folks have been using instead of prints, they've been putting string. Yeah, and so I think that's the other one. And then you can have instead of all those prints, you
Because that works if I do tabs, but if I do instead nothing,
I think if you
it
can
gives
apply
the error.
to it, like if you use it, like.
oh, returns on type. So if I put in a tab.
Oh, you're right.
Right, and they always use.
Cool.
Yeah.
Indentation.
Cool. Of course.
And just want to clarify, like
The most I've done.
the length
Oh, yeah.
function is the method. It's not method because like it's a function
No,
associated with. Oh, sorry, no.
Count.
I refer.
Yeah,
Yeah.
yeah.
Count is the method.
Yep.
Method just means the function associated with specific object.
Yep. Exactly. And there's many, right? So that was when we typed dir for just some random string, AST, and then press Control, return. Then we get here's the list of a whole bunch of methods for strings. Cool. Let's stop recording. Perfect. We're done.